Good afternoon, everyone. Welcome again to the second session this afternoon for the seminars. This session is called Maintain Your Home, and it will be presented by Gary Toulouse for about the next half hour or so. A bit on Gary. Gary has worked extensively with First Nations over the past 20 years. Working as a technical advisor in the housing and infrastructure industry. He has specialized as a building inspector, energy advisor, ensuring that First Nations housing meets building code requirements, and he has also assisted with energy efficiency upgrades to the housing stock. Gary has assisted First Nations with building capacity initiatives in areas such as building code training, building science workshops, residential mechanical ventilation, energy efficient design, and indoor air quality. With years of experience and a detailed understanding of newer building requirements focused on energy efficiency, he is able to assist First Nations with the direct applications and the design and construction of new tighter building envelopes, and the importance of mechanical ventilation, higher insulation values, proper sizing of heating appliances, and the most economical fuel source available to a First Nation. So let's give our time to Gary. Please use the chat, and also if you have questions, you can post them and we will ask them following Gary's presentation. So Gary, the time is yours.
All right, Miigwech, Clarence. As Clarence mentioned, my name is Gary Toulouse from Sagamore, Anishinaabe. And I most recently was working as a planning infrastructure director. And we were able to maintain our housing stock in terms of existing housing going back 30, 40, 50 years and bringing them up to code, and then dealing with the new housing stock and all the advancements in building technology, getting into the ICF, building a tighter building envelope, looking at properly sizing our heating appliances, and looking at available fuel sources, which become critical when you look at everything and you want to build efficient homes and have some cost savings to go with it. Or if you get to advanced building technologies, how do you make it more economically feasible to do so? So we tackled a lot of those issues in Sagamore specifically over the last 8 years. And I'm going to touch on that experience as well. But as Clarence mentioned, I was a building inspector / energy advisor / trainer for the last 15 years in the First Nations building industry. So that's what my approach is. It's for home maintenance. And we're going to focus on new construction to help minimize some of the issues that are faced with First Nations in terms of not doing their housing construction properly and stuff like that. So anyhow, let's get into it. We'll look at some bullets, some project goals. So one, as I mentioned, understanding the importance of general home maintenance, new house construction versus existing housing problems, indoor air quality concerns and remedies, housing maintenance programs developed using asset management principles, and investing in a replacement reserve fund. Key elements in developing a very comprehensive home maintenance regimen or program. And one of the things I always found very effective was coming up with a plan. And as we go through this, hopefully we can touch on some of the tools that are available to First Nations communities in developing a plan. So the modern new house construction developed over the last 20 years has a tighter and airtight building envelope, which if not managed properly may pose significant indoor air quality problems such as moisture problems, potential mold development, and indoor air quality, which can cause health issues and respiratory problems. If the air is not moving and you keep on adding moisture and potential leaks or problematic areas in the building envelope, possibly mold development. Or if it's too tight and you're not ventilating, then if you're housing particulars in the house like gasoline containers, spray cans, all that stuff stays within your building. So that becomes important. Ventilation. First Nation housing is usually designed for a family of 2 parents, include 2 to 4 children, but it happens more often than not. A First Nation house can house an additional family or relatives, thus creating an overcrowding issue, compounding IAQ problems and social and potential social issues such as mental health. As we know, when you overcrowd a house, you really don't have too many places to go, too many places to have some privacy. And I don't know how it goes with everybody else, but a lot of difficulties with the new COVID-19 stay-at-home orders. You know, if you're not allowed to go anywhere, you're essentially stuck in your home, it becomes even a bigger issue. Housing in First Nation may meet minimum requirements of the National Building Code, but the addition of energy efficient requirements pose significant issues as well, as in terms of affordability or increase in the cost of construction, as cost savings may be diverted from other areas such as flooring, cabinets, your trim, energy efficient windows, complete with proper air sealing, number of rooms, full basement, foundations, heating, and ventilation requirements. So essentially, you know, you're building an airtight house, and it may ask for higher insulating values, either in your exterior walls or your insulation. When you start dealing with some of the new technologies as well, it's actually kind of a good issue where you're sealing your house. So when you heat it, that's going to stay within your building envelope. And if you have proper size ventilation, then you're going to have fresh air. Your moist laden air will be exhausted with fresh air coming in. So that'll help with some of your air quality issues. And
Gary, sorry to interrupt you there, but you forgot to share your screen. So if you're showing your PowerPoint, we can't see it.
Oh, geez. Okay. Sorry about that.
No worries.
Okay, let me see here. Okay. Okay, so are we all good?
Yep, you're all good now. Go right ahead.
Okay, because yeah, my first time doing Zoom, so but everybody's able to hear me and understand me.
Yep, you're all good there.
Okay, okay, all righty. 1 second here. I just got to do something again. Okay, there we go. All right, so housing design should be driven by the First Nation membership input. This will ensure proper housing is planned for all members, be they single family, seniors, and single people, or what I've experienced now is transitional housing, meaning that a community member, family may have come into the community and they require housing. And sometimes I notice some communities that I've dealt with will develop a transitional house where you come in, may stay in there anywhere from 2 to 3 months to a year until a full house opens for but so that's what transitional housing is. This approach will ensure that a focus on community needs are met and adequate design principles can be met as well. Develop a budget based on design needs of the community. So as I mentioned, it becomes pretty important when you're planning your housing needs for your community. And a lot of good measures is community engagement and, you know, sending an invitation out to the community members, you know, explaining what you want to do, and hopefully it brings them out to come and help you plan for your housing, because at the end of the day, you know, they're the ones that want this product and they want it to be as cost efficient as possible and to have, you know, certain expectations from year to year, and because you can always reference that plan. So as I mentioned, some of the old principles, you know, may not have applied. You know, we're looking at an old installation of an exhaust fan, and chances are it probably wasn't sealed with the vapor air barrier. And if you're looking at a bath fan, what happens in your bathroom, that's where a lot of your moisture is created by the shower, by your toilet, you know, by kids, you know, washing and stuff like that. And then on the right side of it, as you can see, that's a bath fan at the construction stage. The pipe is insulated. It's taped to the exhaust fan itself. And as you can see, there's a vapor barrier in and around the exhaust fan. So simple installation when you look at stuff like that. So existing housing poses major concerns in terms of design, size, meeting minimum national building code standards, foundations, insulation, and air tightness. Older homes have a minimum insulation value, air vapor continuity, especially on areas in the exterior building envelope, walls, and ceiling penetration, insulation and vapor barrier, floor headers, exterior penetrations such as plumbing vents, air vents, electrical work. So you look at a house maybe 20 years ago, they may not have not been as restrictive as they are now. We're saying, okay, we need a vapor barrier. You need that to be continuous, especially with your penetrations through your walls, because at the end of the day, you have higher insulating values and you've wrapped up your house as tight as possible. You look at your ceiling vapor barrier connecting with your wall vapor barriers and your penetrations like a window. You're going to seal that vapor barrier to that and also maybe apply some caulking around that window. So you're getting a fairly tight building envelope. But prior to maybe years before that, where it wasn't as stringent, you know, doors probably weren't sealed as well. You know, we had issues with improperly installed insulation. Maybe your air vapor barrier connections weren't as prevalent and stuff like that, which causes, at the end of the day, a lot of problems. And you may not have had a range hood or even a bath fan, and definitely not an HRV, because I think those are relatively new, 20, 25 years until they start honing those devices in. So an illustration here, the air vapor barrier connection, as you can see, there's a caulking material in there. And it also has to be compatible. You just can't throw anything in there. And sometimes you see a lot of red tape that works as well, as long as it's done properly. And as I mentioned, you see the ceiling wall connection is sealed. And then you look at the window penetration there as well, it's sealed. And if you look closely enough, there is a bead of low expansion foam. So that's why I mean, this is a kind of a new construction component versus old. So what we got here next is looking at some of the technology that's out there now. And one of my experiences is furnaces, oil-fired furnaces to be more exact, and also maybe wood as well. Most often not, they were oversized. The houses at that particular time may have been fairly drafty. You know, they're breathing on their own, they're bringing their own air in and stuff like that. And then as you moved on, and if you're using the same kind of appliance or what actually sizing a heating appliance, and you tighten up that building envelope, so that big furnace may be rated for 80,000 BTUs, and the house maybe only requires 35,000 BTUs based on your heat gain calculations. And so now you got a big old furnace in there and it's operating inefficient and just spewing out your heated air through the chimney, you know, and stuff like that. So I'll read on here. Heating is an issue as most communities may not have properly sized a heating appliance to determine if the house requires ventilation and if the right fuel source is selected. Moisture is always an issue with residential buildings as occupants produce moisture on a consistent basis and/or external sources such as rain, groundwater. So ventilation will assist with interior moisture. Good site selection and proper foundation drains will greatly minimize the inflow of water into the building envelope. Heating appliance selection and sizing may at times be overlooked, but should be prioritized. Heat loss, heat gain will greatly assist in properly sizing out your heating appliance. Ask the designer to provide this, the HVAC contractor, or ask your technical advisor either through your tribal council, or if you're affiliated with Ontario Precision Tech Services, you can provide the service as well. Also have your tech advisor review available fuel sources. So we're touching on two very intricate components of a building envelope. So, so one of the things we want to control is moisture production and try to greatly minimize it. And sometimes, you know, when you have penetrations through your building, up through your ceiling, through your wall for your chimneys or electrical, sometimes those won't be sealed properly. And in terms of site selection for your residential homes, you really want to stay away from wet areas, problems with water table. And if you do, you know, have your tech advisor come in there and help you out and you know, try to either do another site, or if it's the site you have to work with, then you could come in and say, okay, recommend something like backfilling, and get off the water table, you know, simple things like that, you know, a good building inspector can provide. And one of the things that I've experienced and working with energy efficiency with the HOT 2000 program and mechanical ventilation, because it got you into heat loss, heat gain. You know, basically you model your house in some type of a spreadsheet. You enter your house in there, the size of your house, the kind of insulation it has, fuel source. Then you do an air tightness test. I used to do the air tightness test with a blower door. And you put all that information inside the spreadsheet, and it comes out with your system, with your heat loss, heat gain. It tells you what size of a heating appliance that you can use. And most often than not, if you have available, we'll use natural gas. Say if you're close to natural gas, then you could get a multi-stage heating appliance that's direct vented, so it controls its own air in and out, is one source. I myself, my experience with this is I'll reference my own home community of Sagamok and Schnaubeck. And one of the things that we dealt with, we had fuel oil-fired forced air furnaces, then also hot water tanks. We use oil for our hot water tank heaters. So we had the two things, and we experienced maybe about 8 years ago a major compliance issue where the oil guys were saying, okay, in order to be compliant with insurance requirements, they had to change out all the oil, hot oil fired tanks, and then they were to come back. And so when they went through their cost of doing this, it was relatively high. And we looked at it, and we looked at the options, one being electricity. We're looking at, you know, the science of our current building stock, which was 20 years ago, and replacing everything with 11 years. So we looked at the whole thing there, and we decided to go, well, myself being, I guess, quite knowledgeable of energy efficiency and heat loss, heat gain, was allowed to say, made a decision. Let's work with a propane fired appliance, which gave us a wider range of meeting the heating needs of our current housing stock. So we're able to get greater efficiency out of propane. Not only do we get greater efficiency out of propane, but we're also able to have a lower cost of fuel source. I think when we switched over to propane versus oil, I think there was like a 35 to 40 cent difference per liter. So it made it more economical to do that. And once again, I stress that, you know, for First Nation, you know, when you look at your housing stock and how much detail you got, then you can get that information from your tribal council or FNHC service provider to help you with that information. And I know that, but up north you have different needs. Say than for myself, which is the mid north. I'm located just outside Sudbury here, but we don't have access to natural gas, but we do have access to propane. Makes that more economical for our neck of the woods. So I did use as an example here a properly sized gas-fired direct vented furnace with HRV, and as you can tell, there's plastic piping coming out of the furnace, and it's controlled by an ECM motor. It it's an energy efficient motor, and it interchanges multiple speeds depending on your needs. So today it's plus 13 outside. It's kind of overcast with moisture. So if we were using the furnace today, we'd actually have it at say 10 or 15, and it kick on, keeping our house nice and comfy here. And as I mentioned, there is also a direct installation for an HRV. Looks like it's independently installed as well outside the ducting for the furnace. So I list some common problems and solutions. One of the things I like to focus on is the building envelope, and some common problems that we experience out there. And I think that a lot of us get affected by it if these aren't consistent. So one of them is a failure to properly seal air vapor barrier. A proper seal will minimize the amount of air entering the building envelope. Exterior air will cause drafts or cold spots. Interior moisture-laden air will penetrate the insulated cavities, causing moisture damage and potential mold growth. So your air barriers on the exterior of your house, you want to ensure that's tightly sealed, because you don't want exterior air influencing what's happening in your house, because you'll start creating those cold drafts or cold spots in your house. And same thing with your interior, you don't want that inside your building envelope, either in your walls, or you see a lot of it happening in your ceilings through your lighting penetration, or at times we have a chimney, it goes up there if it's an interior chimney, or plumbing stacks, you know, all this stuff. Yeah, you really want to minimize those situations. Insulation installation is a critical component, as this minimizes the amount of heated air leaving the building envelope through air leakage and poorly installed insulation, low R-value insulation, and wall and ceiling cavities. You know, if you have a weak spot in that building envelope where the warm, moisture-laden air is allowed to go or accumulate, you know, sometimes that's why you see the corners of your walls in a susceptible area, usually maybe possibly on the north side, or in your ceilings. You know, you don't put proper insulation in there. You know, you go in their corners and you scrunch it just to fit it in there. That's not the way to do it. So there's, you know, a few things that can be done to minimize that. One of the items that happened there, a lot of communities started grasping, was raised heel trusses. So then you're able to slide your insulation in there, get it fully, because that compressor doesn't work as well. Put it in there, full install. The same with your wall insulation, you put it in and make sure it's nice, fitting in there firmly, and there's no scrunching of it. And seal all penetrations through the building, such as vent pipes through the roof. Use proper materials and waterproof sealants for exterior applications. So essentially, when you're looking at your roof, critical, make sure you use the proper boots, the proper exterior sealants, because, you know, if you use something that can't handle the high heat of a roof, you know, potentially premature failure. Wall penetration, such as ventilation, water pipes, electrical power coming into the house, puts a fairly big hole in there, and electrical guys just come in and leave that big hole in there, and it's up to the contractor, you know, seal that up as the penetration goes into the building envelope. And then if it's going through the siding as well, put an extra sealant around that, and you start minimizing exterior going into the building envelope. Ensure all exterior claddings are properly installed and seal all window and door openings. And same thing, siding, if not properly installed, and get water pooling in certain areas, going in through your windows, getting into your wall cavities, rotting those window and door openings. And that happens quite often. I've seen it quite a bit, and it costs a lot of money, because if that wall or that frame is deteriorating around those windows are heavy, as an example, and it starts rotting it out. So that window starts moving, you know, what happens when that window starts to fail as well, And I'll use picture window. Those are fairly heavy, and so those things start moving in that wall cavity, and the window fails. So you go from, you know, a simple construction practice to having some major failures in that building envelope. And if you're not planning for it, then it becomes quite expensive. So a tight building envelope requires adequately sized mechanical ventilation, which can be accomplished through a heat recovery ventilator, a bathroom fan, and range hood. Have your HVAC contractor, designer, or technical advisor size your HRV for your house. Ensure the bath fan and range hood vent to the exterior. See all penetrations through the building envelope. Very important. Sizing of HRVs, I think at one particular time, you know, when they were first starting to be implemented to housing, they were fairly big and fairly bulky. And I don't know if they were properly sized for the house. And and if you aren't knowledgeable of HRVs, and then these could actually suck, if not properly, so a lot of issues can arise. And depending on the situation, some kind of resolution from a qualified expert, mechanical ventilating contractor should be able to come in and help you out with that. Or if you have a good tech advisor, they should be knowledgeable in that as well to help size out or replace the HRV. As I showed you earlier, make sure the bath fan vents to the exterior. Best, as we showed you, wrap it, insulate the pipe, seal it to the fan, and then good installations, you exhaust through the roof. As soon as you penetrate your building envelope, make sure everything's sealed, make sure there's continuity with the vapor barrier, make sure there's continuity with the penetration through your roof and your roof shingles. You're using the right boot and the right type of sealant. That should minimize, that's a good installation practice. Improperly stuffed, you know, I see a lot of failures with using the wrong caulking. You know, guys use silicone for exterior for a rubber application, and with excessive heat, you know, it tends to expand, and winter comes, it extracts, so it fails quite easily. And another one that I've experienced quite a bit, and at one time, range hoods, you know, you weren't vented up to the outside, and you just kind of kept everything inside. You know, the thing with when you're using your cooking stove, you know, you tend to boil water. You know, you're creating heat. You're cooking your food. It's all creating these possible moisture, aromas in the house. If you burn something, you're going to smell that there as well. And so now I always make it vent your range hood to the exterior, and that's what it's the best use for, instead of not venting it at all and trusting that the manufacturer is giving you the right installation procedures. And so one of the remedies I used to always do or recommend was change out your range hood. Could fail eventually, and then new installs, vent to the exterior, and same thing, wrap the pipe, seal the penetration of the vapor barrier, and make sure you have the proper range hood vent, which is quite important because some people don't have the right range hood vents, and usually the rectangular, they stick out. So, all right, so another one I mentioned before was site selection and foundation drainage. So when selecting your site for your building, ensure the groundwater is well below the bottom of your footing, and ensure proper backhoe is built prior to construction of the foundation, as this will assist in minimizing groundwater into the building envelope and frost protection if it's required, depending, I guess, what type of foundation that you're using. Additional measures may be needed here, as frost protection may need to be installed, and frost protection is basically if you can't penetrate down too far below, in order to protect your footing, depending on building code requirements, it's usually a rigid insulation that's installed at the footing, or if it's a slab on grade, around the perimeter of the slab. And you can go out anywhere from, I believe, 4 feet to 6 feet, depending on what the building code requirements are. And this here, all depends on your communities. I think a lot of communities may possibly deal with water table issues, and that's what's always recommended. If you can't get away from it, and that's the only suitable site to build, you could backfill it in, get off the water table. A good guide that I used to do, I used to follow whatever the environmental health office they recommend for a field bed. Develop the map for the field bed. He says raise it up so high, because you got to have positive drainage from your house to your field bed. So I always recommended, just go a little bit higher than what's recommended by the HO. So get off the water table and have positive drainage into your septic tank and field bed. So it's a good guide for you, but also it's one of the things that ask your service provider, when you're looking at site selection, looking at foundation drainage, because if you're in a high water table area, your foundation will always be consistently having moisture problems, which wicks up into your floor system. And if your floor system is wood, moisture, heat, cold, eventual failure. I know several people that happened to, even though I told them, I said, get off the water table and don't dig a hole. I was telling guys, don't dig a hole. But they dug a hole, and sure enough, the floor system issues. Foundation is critical. Foundation drainage is critical. This will greatly protect the building from external water penetration. Technology such as a blue skin, good example, it's that oil-based skin you apply to foundation walls that works fairly well. With a proper foundation drainage tile, wrap it in a sock, and cover it with the granular layer, at least 6 inches, and make sure the foundation drain tile drains well enough away from your building. Try to get it maybe even as far as the ditch by the road. So as long as you have that continuity, that's going to flow out of there and not accumulate within the building. And one of the things that I noticed too, and if you're having water table issues, and I noticed that people will put a sump pit in there, and so basically you have a hole in your basement, and you're having water table issues. Say in springtime, this is what I noticed. A lot of people that have water table issues, and the water just comes up. They're always constantly working their sump pumps, and their lives actually revolve in and around making sure that sump pump is running. They might even have an extra backup there to cool off the other one. So the importance of foundation drainage, the importance of paying attention to water table, and having a good technical advisor to tell you, okay, what site is suitable and all that stuff.
Hey, Gary.
Yep.
You have under 10 minutes.
Okay, I think I'm almost done. Foundation drainage system. Foundations wall covered with blue skin weeping tile with permeable socks. So here's a description of what I said. And as you notice, it's a sand and there's no water table issues. Indoor air quality issues and remedies, usually caused by excessive moisture in the building envelope. Once detected by the homeowner, a soap solution can be used to clean the area. If it quickly comes back, make a note of it, contact your housing department. They can then stand in a qualified building inspector to determine the cause of the moisture problem and write a remedial solution for the situation. And you can always reference CMHC's molded housing information for First Nation occupants. Excessive moisture on pipes can create condensation, possibly leak into wall and ceiling penetration. The house may need proper ventilation, a properly sized HRV. The rain chute and bath vents to exhaust exterior, install pipe insulation on all piping, storage of fuel products such as firewood, gasoline, diesel containers, aerosols, and other VOC products. Store these products outside of the home. So as I showed you, here is a moisture problem, and as you can see, there's suspect mold on the wall, and that is in a basement. It looks like that's a penetration for the water. So one of the programs, working as a director of planning infrastructure for site with Fishnallbeck, they had they were an ISO licensed community or certified community. And one of the principles or programs that they brought into the infrastructure department was asset management. And we felt a strong need that we had to have a solid approach in terms of our housing and how we maintain our housing stock, because that was the community's biggest asset. You know, outside your roads, your water, your community buildings, housing was still our biggest asset. So, so one of the things that they done in and around that was develop a work order system, and that was based on the housing needs. And they also had a housing needs study telling them how to develop their housing plan, housing needs for community needs. And then there was a housing regimen attached to that as well for existing, and being able to set that up, because it'll determine common deficiencies that they had to do repairs on, short-term, long-term, major repair. Also, it made them pretty organized in what they were doing. So when they're developing their work plans for the housing stock, then they'll say, okay, we can do this year, here's the budget for it, so on and so forth. And it was well maintained by the staff and well coordinated by our housing committee as well. So one of the things, you know, that drives a lot of housing needs is the housing list, which then drives your budget as well. Or housing list will drive your housing need, develop your budget. The housing needs study should cover the community, as this will capture the actual housing needs such as single family dwelling, duplexes, elders, foster home, and apartment complexes for single people. Request a technical advisor available through your tribal council or FNHC to assist in development of a community-based workshop to attain the feedback of the community needs. Possibly hire a designer to develop and finalize the housing needs study. The study will determine the number of units required based on this feedback and coordinated with your community list. A housing development plan can be incorporated complete with budget. The housing needs study can focus on the current housing stock, determine common repairs and cost of repairs and priority of repairs. Utilize your building inspector to inspect current housing stock. This can be a service offered by your tribal council or FNHC. This approach will help immensely with this component. Track your repairs with a work order system. Repairs can't be implemented without a work order, and track through an asset management program, or very simply through a spreadsheet or an accounting program. A healthy house which is adequately sized, properly heated, ventilated, and annually maintained can last a very long time and keep up with the well-being of the community. So another big component, investing in your replacement reserve. Sagawak had been through this CMHC Section 95 program, so I'm speaking directly from my own experience with Sagawak as the building and infrastructure director. So once they developed their housing plan and put their home maintenance plan into effect, I guess is a better word for it. So they were able to plan for replacement reserve. One of the things that I mentioned when we changed out the furnaces, there was maybe about, you know, five years from replacement time, but we put the plan forward, you know, based on information that we had internally to say, okay, well, let's start putting in a plan to change out furnaces. We kind of phased it in over the last 5 years or so, and based on information that we had, we were able to upgrade to propane, which is an available fuel source. The heating appliance itself, forced air furnace, direct vent, you know, made it very highly efficient for us, and also safe. You know, people, when we had oil there, people were filling their own tanks and not using the fuel company. So that was an issue there. That was another issue we had to deal with. And that was a big expense, because if we would have stuck with oil, that would have been, I don't know, something, I think roughly $3,000 to $4,000 for us to change out to an oil furnace or change out from an oil furnace to a propane. Didn't have to change nothing more than either taking out that oil furnace, some adaptations to the ductwork, removal of the oil furnace, and basically when we rented the signed a contract with a propane company, they provided a rental fee on top of their oil tanks. So it was like $10 a month or something that you paid for your meters. And we cut down our energy, our heating energy down quite substantially. I don't know if it was a half or 2/3. It was quite substantial and a lot cleaner. So that's why I find that when you plan everything well and you use your replacement reserve, you're able to adapt with changing times. And as we know that some of the stuff that we deal with, you know, one of the big numbers that stick, or one of the big issues that sticks out is shingle replacement. When you're replacing 10, 15 houses with new shingles, that becomes actually quite expensive. But if you plan everything right, you say that house has a 15-year-old shingle, you start making sure you have the money to replace that, and then just do your how many units you need to replace and just phase it and so on and so forth. So one of the things I just mentioned earlier, and so when you, as a homeowner, these are simple things you can do. A major component of your house, these have a life cycle expectancy, or maybe need to be replaced prior to your life expectancy expires. General maintenance such as filter replacement, annual inspection, or general maintenance by a qualified HVAC contractor can maintain its life cycle expectancy. However, when it's time for replacement, these can be cost replacement spells, so budget replacement is a must. And yeah, filters, you know, it's pretty easy stuff we can do. It helps your furnace run better, more efficient. I do this myself, and your HRV as well. Same thing. You just do general maintenance on yourself. We have a heating contractor that comes in maybe every 2 years, make sure that the appliance is working properly, and if there's a break. So it's just kind of preventive maintenance can go a long way. And as I mentioned as well, windows and doors, another major expense for replacement. A lot of communities, you know, you see some of the windows, they're foggy, or you have moisture in it, or you don't open or close, and they are quite expensive to replace now. And that's something that has to be well budgeted and well coordinated and executed with the right contract. And one picture, and this is probably a picture we may see consistently through our communities, window with the seal failed, causing moisture leakage to that window. And you put in the heating season, you know, your doors are closed, windows are closed, you know, your heating appliances on, you may not be venting, so you know you're creating moisture in that house. And the weakest point, that building envelope, is the window. In this case, it's the window. And you know, eventually, as a homeowner, you go, okay, I just want that thing replaced because maybe there's failure within that window as well. And that's it. Thank you much for your time. It was my pleasure providing information and solutions for common housing maintenance issues, either repairs or procedures for maintaining your housing stock. My name is Gary Toulouse. I'm with the Well Summit Consultant Services, and I can see there's my contact information. And if anybody has any questions, you know, feel free to ask either myself or Clarence. And I believe, yes, I'm open for questions.
Yeah, thanks a lot, Gary. Thanks for sharing the session. We are out of time. So what we will do with the questions, there's probably 7 or 8 questions that came up on the feed. So we will record those and pass them on to you, Gary, and we can post them to your seminar spot so people can follow up with the questions on there and the answers. So thanks again, and we do have another session to get ready for here. So Gary, thank you for sharing with us today. Very valuable information, a lot of information. So we certainly look forward to you know, follow up with that and hearing more about home maintenance. We will, the conference has provided a gift of an art print for you, Gary. So that will be sent out to you. So thank you again for sharing with us this session. And attendees, again, we will follow up with the questions to Gary and put them on the spot on the platform for the this particular seminar spot. The passport to prizes. So if you go to the homepage on the platform, sorry, there is the spot for passport to prizes. Go on that spot and then pick this particular session.
Wi-Fi.
Put in that code and the code healthy. So write that down, put that in that code, and you will get the points for attending this session. Also, we ask if you could complete the survey at the bottom of the page. There's a 5-question survey that helps us in planning as well for future events. Thank you, everyone. We will be back here in a few minutes with a new session. The next one in this stream is Introduction to Cellulose. Of course, there are 3 different streams you can choose from. At 4:45, we will be back. So thank you.